Okay, so this morning we'll start a new chapter. Am I sharing you my correct screen? Let's check. Okay, correct. Okay, this morning let's start a new chapter. The chapter is on chapter 2. It's forces and motion. Let me just type out for you what is inside this chapter. This is already in the folder, so if you need to access the Jamboard, you can just go to the Jamboard. It's all there, okay? So what is inside this chapter? There's speed and velocity. There's acceleration, free fall, force and mass, friction and braking, gravity and weight, action and reaction, vectors and scalars, and then circular motion. So this morning, let's start with the first one, speed and velocity. Change the color a bit, not so boring. Come, let's get some nice picture also. Come. Okay, so what we will start with is let's start with speed. The picture never load. Never mind. So let's start with speed and velocity. Have you heard this term before? Velocity. Yes, but forgot. Okay. Never mind. Can you tell me what you can remember about speed then? What is the formula for speed? Do you remember it? Distance over time, correct. Have you learned about the concept of displacement before? I think not. Okay. Do you remember the meaning of displacement? No. Okay, then before we do that, let's learn about distance and displacement first, because it's related to speed and velocity. So because I'm just following the textbook. Okay, so distance and displacement, what's the difference? Okay, yeah. Before we go into that, do you remember what's, I forgot, before I jump into this, do you know the difference between scalar and vector? Have you learned vector before? Have you learned scalar and vector before? Oh, you saw my YouTube. Did you understand it? Now know a little bit. Okay. Wow, not bad. You watched the YouTube. Okay. So from the video, what did you understand about scalar and vector? Let me put it this way. Okay. Vector left? Okay, that's different thing. So maybe the video not clear enough. So no, it's not really that. It's not a scalar, it's base and derived. Base and derived are different things. I create another Jamboard for you. Base quantity Base quantity just means the quantities that cannot be derived from other quantities. Quantities that cannot be derived from other quantities. It's different, huh? So physical quantity is the main topic. Physical quantity is any quantity that can be measured. Physical refers to measurable quantities. Okay. So physical quantity means the name of the thing that can be measured. Length, time, mass, volume, area, speed, all this can be measured, right? That is a physical quantity. So physical quantity, we can divide into a few categories, right? We can divide into base quantity, can also divide into derived quantities. Derived quantity. A derived quantity means quantity that can be derived from other quantities through multiplication and or division. Okay, what does that mean? So base quantities, there are only 7 that exist in this world. Length, mass, time, electric current, temperature. Okay, the last 2 normally we don't learn. Amount of substance and luminous intensity. So that means all the one I mentioned just now is what the length, time, speed, area, volume, all this can be measured, right? But in this world, got 7 base. This 7 base means this 7 is the most basic one, the foundation for all physical quantities. So in physics, we only focus on 5. The top 5. Why? Not to say number 6 and 7 like not important. It's just that we don't learn in physics at IGCSE O levels. Number 6 you will learn in chemistry lah. Number 7 maybe you learn in A levels. But for O levels, right? IGCSE we will focus on 5. Number 6 and 7 never come out in this chapter, in this syllabus. The textbook, the whole textbook tada. Okay, we only learn this top 5. So that's why we will just focus on 5. So a lot of times when you read certain website and all book, they also talk about the first 5 only. So what it means quantities cannot be derived from other quantities. Means normally how you get the number is normally you have to measure. You take the ruler, you measure. You take the stopwatch, you measure. That's what they mean by cannot be derived. But when we look at derived, let me explain derived, then you can understand the base better. So derived quantities are quantities that can be derived from other quantities through multiplication and or division. Meaning, like if let's say you want to get the value, like just now you gave me speed, right? Speed, how you count, you told me just now, distance divided by time. So you see, like you look at the formula, like speed, you can calculate, or actually you can measure also. Use the speedometer, the police use for the speed trap. You can also use that. But another way is you calculate using the formula, or speed equals distance over time. So that means, and you see like, this is distance can be measured. It's actually a physical quantity. Time is also a physical quantity. That means derived means, put the meaning here. To derive something means to get something new through a new process. Through a process. That means you take something, you process, you get something new. I put the meaning here lah. I put the different color. Okay. By example I give you an example. Let's say like in real life if you have an orange, then you put the orange in the machine, press, get orange juice. is a process, and you get something new. Orange is a solid fruit. Orange juice is a liquid. So the orange juice is derived from the orange. It's like you take something, you make it go through a process, you get something different, something new. Okay? So in physics and maths, because physics is like maths, when we derive this, right, means we take other quantities. So you can see, this one is distance, is another quantity. It's how far, time is how much time that it passed. But speed is what? How fast something is moving. We take other physical quantities, we process by dividing, you get a new one. So that's why speed is considered a derived quantity. Can follow so far? Can, another example, let's say I want you to count the area of the rectangle. Okay. How to count the area of the rectangle? Do you know the formula? Correct. So area of a rectangle is area times area pula. Picture. Length times width. Length times width. So then you see the formula. This one also is different quantity also, because you have what? You have length. You can measure there, length. Width is actually same as length because it's a different name. The same thing because you think a length and width actually different name for kind of the same thing lah. It's just that the name is just so that we know where is what lah. We know we know this is the length, this is the width. It's just to differentiate. But when you look at it, it's actually kind of same. Then you take the length. What happens? You times. It's a process. You times it. Then you get a new quantity, which is the area. So that's why this is considered to be derived quantities. Base, you can't use this formula to count one. It's impossible. Like not impossible lah, but it's more like it's you cannot. Other quantities you can. You can take other formula, you times, you divide, combine. Sometimes now only put 2, but can even have more. 2, 3, 4, 5. Example lah. I give you example. Let's say like density. Density is mass over volume. Then you see carefully, volume, if you count volume of cube, is length times width times height. So that means it can even become length times width times height. Wow, that is complicated, can become more and more complicated. But regardless, the concept here is just to explain, these are derived quantities, right? That you take other you take other physical quantity, you times divide, you get something new. So that's base and derived quantity. Can So then the scalar and vector is different. Scalar and vector is like another new set of category. It's not related. It's different from base and derived. That means it's another way to divide the physical quantity. So another way to divide, meaning you imagine like it's just a different way to divide, meaning like sometimes when you like you must imagine like the physical quantity, right, that exists in this world is like thousands and thousands and thousands. You imagine, I'm just going to draw random things here now, okay? So let's say you have the physical quantities. For physical quantity, okay, my writing is very bad. I don't know why is it so bad. Okay. Physical quantities, you got a lot, it's everything that you can, the name you can measure when length, speed, time, area, volume, mass, temperature, all these are physical quantities, and they got thousands and thousands in this world. So the one way to divide them is to put base and derive. So that means it's like you imagine like you got let's say now it's only your class only got one person lah. But next time, let's say you have a class of more people, then you can divide. Okay, so we divide into two groups, one group of boys, one group of girls. Or don't go with boys and girls. Let's say we have this group. Now let's say we divide we divide into different group, like who like physics, who don't like physics, different group. Sometimes it's not boys and girls, some boys like physics, some boys like some girls like physics, some boys don't like, some girls don't like. So it's just different way to divide. Okay, or like, oh, who likes red, who don't like red, you know, or who likes sports, who don't like sports. So it's basically it's like a lot of physical quantities. We just divide it. We have different ways of dividing. So scalar and vector is not related to base and derived. It's a different way to divide. Okay. Okay, that one was not no meaning lah, but just like to sketch. So scalar is what? I use sticky notes. Scalar quantities are quantities that have magnitude only. Do you know what magnitude means? Correct. It's magnitude. That means got value only. Vector got magnitude, but also have direction. So what it means when we say got direction, you see, a lot of the quantities you have learned so far, a lot of them are have magnitude only. Example, okay, length, time, mass, temperature. Not only these are now, because I know I put base quantity, but not only this, even area, volume, density, all these are scalar quantities. Means like, means what? So you see, although got base quantity here, also got some derived. But means what? What means magnitude only? So means because we are comparing direction. We are comparing direction. Direction. So the key word here for is that the vector got direction. So what's its direction? Okay, for scalar quantities, the direction is not important. No, it's not important. Sometimes don't even exist. Like time. Time where got direction? Direction meaning what? Go left, go right, go up, go down. Time where got direction lah. Time is just you start stopwatch. How much time pass? You know, there's no direction one. Length. Like you measure the length of your book. Where got direction? Go left, go right. How you measure also is the same. If you measure, let's say the length, you measure from top to bottom, bottom to top, doesn't matter because it's the same length. You measure how also is the same length. Okay, so that's why you think about it. All these things, yeah lah, memang got no direction, what? Because since when got any direction meaning, like make no sense, what? Yeah. So that's for scalar. So all this while, a lot of the things you learn is memang scalar. There's no direction, what? Vector got direction. One example of actually got quite a lot, but for now I talk about the easiest one, force. Okay, so the force, right? You learned force before, right? If you apply a force, okay, you got learn force before. Okay, easier and good, and then it's easy to explain. Let's say I draw out for you two examples lah. Okay, let me put here. So let's say we have a situation here where we apply two forces on the same object. Let's say this is both objects is the same lah. Object, both, I don't put A lah, let's confuse you. Both is the same object. Why I shade like that? Blur kiss me. Okay, same object lah, same object. And then we apply force of the same magnitude. So one force we apply is 10 Newton this way. One more force we apply is, let's say, 5 Newton this way. Then one more, we apply 10 Newton this way, and we also apply 5 Newton this way. So you can see in both situations, we apply the same amount of forces. But now you think, let me call this situation A and situation B. Do you think A and B, the object will move in the same way? Will it move in the same direction? Will it move in the same with the same speed? Do you think we'll have the same result? No. Why not? Why won't it be the same? Different Newton. But the Newton is the same. This one is got 2 here, ma. Here got 10 and 5. This is my mouse. Here got 10, here got 5, here also got 10 and 5. It's the same force value, right? Direction not the same. Yes, correct. The direction is not the same. So because the directions are not the same, obviously you will have different results. So when you have this kind of situation, then the direction is very important. So that's what we will learn in physics. We will learn that, okay, now you have to learn about the concept of vectors, where we need to take into consideration the direction also, because the direction is important. If the direction is different, then obviously the results is different also. No? Yeah, so that's why I use first example first. So now after this, we're going to start learning chapter 2, right? We'll be learning a few more vectors, but this is just to point out to you, lah. Okay, that this is what it means when we talk about vectors with directions. Can follow so far? Can, huh? Okay, so now I need to talk about distance displacement also. Okay, yeah. I think we won't go to speed velocity today. We talk about distance and displacement a little bit. I'll put in a few more examples here. There's force, there's displacement, and there's velocity. So let's talk about displacement a little bit first. This one is, we normally start with this, because, even though you learned before, we go through again, because this is important as our basic for the next part. Okay, so distance, right? If let's say we have, this is a road, let's say this is the starting point. So there's one object moving. Okay, Scalar, let's say it's not a Scalar, okay, somebody moving, moving, okay. So this object is going to start moving. I put different color. Okay, distance and displacement. Now, the difference. Let me just talk about example first. I think you learned before, so maybe it's not so bad. I'll put this as O. O means the original position, original point where it starts. Let's say here is okay. Here we got 1, 2, 3, 4, 5. Backwards here 1, 2, 3, 4, 5. So what I'm labeling here is the distance in meters. So let's say this object is moving. Start from here, move here, then go that way. Okay, so it will move like that. Now, when we talk about distance, right? Distance, like, you know, sometimes you walk, they ask, oh, how much distance you walk? You walk lah. Let's say this fella move, move from You don't care the direction. Like, let's say, like, you go for a walk around your neighborhood. They say, okay, walk 5 kilometers. Don't care, just walk only lah. Go round and round and round and round like hamster, like that. Go round and round and round and round. Okay, doesn't matter. Like, how's your direction? You just walk only. In the end, it's like how much you actually move. So if this ball is moving from, I'll label here, from position O to A to B. Total distance, total distance, can you count for me? How much is the total distance the ball moves if the ball moves from O to A to B? 10. Correct, good job. So total distance is 10. Now, do you remember you said you learned displacement before? How much is the displacement now? If not, now its distance is 10. Now, what about displacement? Do you remember how to count? No. Okay, never mind. So for total distance, we don't care the direction. You count because it's 10 because you go there 3, come back 3, another 4. Okay. Now, what about displacement? Displacement, right? The direction is important. The direction matters. So when we talk about direction, right? There's a few ways to express direction. I will just talk about 2 different ways. Direction, you can either specify, I'll just let you know the option lah. You can write it as left or you can write it as right. Okay. The direction can go left, right? That means you will say, oh, object move from O to A is 3 meters to the left. Then go 3 meters back to the left. Say wrong thing. 3 meters go to the right. Then go back 3 meters to the left. Then go back another 4 meters to the left. But then say, how to talk about the displacement? So you can talk about left and right. But another way, which is the way we need to learn to do in your IGCSE syllabus, you write it as positive or negative. Positive, negative meaning what? Positive, negative, right? In physics, normally can represent direction. It's like how last time you learn negative number. You learn negative number last time, it's like, oh, this is 0. You go to the right, it's 1, 2, 3. But when you go backward to the left, it becomes -1, -2. So the positive and negative now can represent direction. So like for example, we can say that, oh, positive is the left and negative is the right. So that means when you look at it for this situation, O to A is actually what? Going to the right. So you can actually write O to A is positive 3 meters. That's the object moving from O, go to A. Then after that, go back to O. A, go back to O, is going to the left. Is going from 3, go back to 0. So going to the left is negative. So you can write it as -3 meters. Then from O, keep going back, now go back towards to B. So O go to B is going to the left. So this becomes -4 meters. So then now what you can do is you can actually pause, even though I say we just positive and negative is like left and right, but when we count in physics, you can use it, you calculate like maths. You just put positive first for the left and right, then after that finish, you just take positive 3 minus 3 minus 4, then you think plus 3 minus 3 minus 4. Plus, you plus all together using the symbol, in the end you get how much? -4 meters. This is the displacement. Can follow so far? So the number for displacement and distance is not always the same. In fact, I show you the long way. I'm showing you why. But the faster way to count displacement, faster way is this. You just take the starting point and ending point, and then you straight away get the value from there. So next time, if you count displacement, you can actually take it as the straight line distance. No, not straight line distance. You calculate you take the displacement as for the magnitude directly. No, not magnitude because it's direction also. You take it as the, how to explain? Okay, let me put it this way. Displacement, right? You can take the displacement, measure the magnitude and direction from the start directly to the end point. Okay, means what? Means this is the start, this is the end, ma. So even though how it go there, come back, go there, come back, doesn't matter. Just here's the start, here's the end. Oh, it go to the left negative. So that's why straight away, yeah, even go O to A to B, you just see the start, you see the end. From here direct O to A to B is negative 4 meters. Straight away you can get the answer. So bad. Negative 4 meters, straight away you can get the answer. So that's like the faster way lah to count. Okay. I give you another example. Let's say, oh, oops. Let's say, right, this one is like they like to use it as an example, so I will give you this example also. Let's say here's your, okay lah. Let's say now once you're vaccinated, can go out already, right? So let's say here's your house. Okay, then you go. Then that's it. We all go out. So let's say here go travel 3 kilometers. After that, first maybe you drop by your friend's house first, pick up something, then go to the mall. Okay, so this is the mall. This friend's house. I call this friend P lah. Then this is your home. So let's say lah, perfect world lah. I know it's not a perfect world. Here is memang like 90 degrees angle like that. So now you look the distance traveled. How much is the distance traveled? What do you think? If you go from the home, go to P, go to the mall. What is the distance traveled? Correct. Now, what about the displacement? What do you think? So in this kind of situation, you're like, how to put the positive and negative? Never mind, no need. You just give me the magnitude. That means now you remember, you can take from start to end, ma. So from start to end, you count your displacement over here. You remember how to count? Let's say this is a triangle. You remember how to count this value? Yes. So how much is the displacement number here? Don't worry about the direction. Just give me the value enough. Okay, counted already? No, you use Pythagoras theorem. No need to use cosine rule. You don't have the angle, ma. Pythagoras theorem. No leh. Wait. You use Pythagoras theorem is a squared plus b squared equals c squared. A squared equals b squared plus c squared. See, I say one thing, two different thing. Okay, you use Pythagoras theorem, not the cosine rule. You can only use a cosine rule on and all that when you have the angle. We don't have the angle. Yeah, it's 90 degrees, but then when you use the cosine rule, it's based on the angles here and here. You don't have the angles there. Yeah. So you cannot, you only use sine and cosine when you have angle, not the 90-degree angle. You know, you have this angle, you have this angle. You don't have the angle, you cannot use the sine cosine rule. Okay. Okay. Just a little bit more before we finish up today's lesson lah. Okay. So yeah, so that's how you calculate. You use the Pythagoras theorem to get back to get the answer. Okay. Now let's say okay, I just draw it's a car. Okay. The car went from home, go to P, go to the mall. Then of course after you finish reading, you must go home. So I want you to think. Let's say now, if we went from home to P to the mall, now we go back home. So home to P to mall, not that we go to P, but it's because it's on the way, we just drive by, go back. So if this happens, from home to P to mall, go back to the P and go back home, what is the distance traveled? Correct, 14 km. What about the displacement? What do you think? Correct, 0. Yes. So it's very strange because a lot of people say that, hey, but we move so much, well, how come the displacement is 0? Because when it comes to displacement, they don't care how much you travel, how fast you travel. We don't care. Displacement, we just look start and end. If start and end is at the same point, it's like you didn't move like that. You come back to where you started, your displacement is 0. Okay. So don't worry about this one. Tomorrow we discuss lah. But for now, you are clear about the difference between distance and displacement? Okay. Up to here first lah, because the next part, now 9:50, 10 minutes left. The next part, I cannot explain in 10 minutes. I don't want to start, then stop. Then, half here, half there. Not this will disturb your understanding. So we stop here first lah. Any questions? No. Okay lah, then enough for this morning lah. I see you tomorrow.